सादर प्रणाम। एनसीईआरटी की वेबिनार सीरीज लिसनिंग टू लर्न, जिसको कि हम आज़ादी के अमृत महोत्सव 75 वर्ष आज़ादी के 75 वर्ष के अवसर पर लाइव प्रसारित करते हैं। मैं आपका एक बार पुनः फिर से स्वागत है। आज हमारे इस प्रोग्राम का 30वां सेशन है, 30th सेशन है। मैं गगन गुप्ता, डिपार्टमेंट ऑफ एजुकेशन इन साइंस एंड मैथमेटिक्स, एनसीईआरटी से आप सब लोगों के समक्ष प्रस्तुत हूँ। मैं इस समय सेंट्रल इंस्टीट्यूट ऑफ एजुकेशनल टेक्नोलॉजी एनसीईआरटी के स्टूडियो से आप सबके सामने आप सबको संबोधित कर रहा हूँ। और आज हमारे साथ एक बहुत ही इम्पोर्टेंट स्पीकर अहमदाबाद से हमारे साथ जुड़ रहे हैं, स्पेस एप्लीकेशन सेंटर अहमदाबाद से, जो कि इसरो का एक स्वायत्त संस्था है, इसरो के साथ है, जिसमें डॉक्टर दीपक मिश्रा हमारे साथ हैं, जो कि आज हमें इंडिया स्पेस प्रोग्राम के बारे में एक ओवरव्यू देंगे, हमें एक अवलोकन कराएंगे कि भारत का अंतरिक्ष प्रोग्राम, अंतरिक्ष कार्यक्रम किस तरह से चल रहा है, आगे आने वाले फ्यूचर एस्पेक्ट्स क्या हैं। व्यूअर्स, आज का ये प्रोग्राम आप हमारे पीएम ई विद्या चैनल्स 9 और 11 पर लाइव देख रहे हैं। साथ साथ आप हमारे एनसीईआरटी के यूट्यूब चैनल एनसीईआरटी ऑफिशियल पर भी आप साथ साथ देख सकते हैं। आप अपने प्रश्न हमारे इस यूट्यूब चैनल के लाइव चैट बॉक्स में लिख सकते हैं। उन प्रश्नों का समावेशन हम इस सत्र के आखिर में लेने का भरपूर प्रयास करेंगे। आप इंटरेक्टिव बने रहें। साथ साथ आप अपने प्रश्न हमारे स्क्रीन पर दिखाए जा रहे टेलीफोन नंबर पर भी आप हमें दे सकते हैं। साथ साथ जो स्क्रीन पर अभी 2 ईमेल एड्रेस और दिखाए जाएंगे, उन पर भी आप अपने प्रश्न हमें भेज सकते हैं। आप अपने प्रश्न और सुझाव आप हमें कार्यक्रम के दौरान भी दे सकते हैं और कार्यक्रम के आखिर में भी दे सकते हैं। आपके सुझाव हमें इस कार्यक्रम को आगे ले जाने में बहुत मदद करते हैं। आप अगर किसी टॉपिक को चाहते हो या किसी स्पीकर को चाहते हो तो आप हमें उनके बारे में ज़रूर सूचना दें, ज़रूर बताएं। आप सबके सुझाव हमारे लिए बहुत महत्वपूर्ण हैं। आज का ये प्रोग्राम, जो कि भारतीय अंतरिक्ष कार्यक्रम के ऊपर प्लान किया गया है, यह दोस्तों हमारे एक पूर्व में दिए गए प्रोग्राम 16 नवंबर को, जिसमें प्रोफेसर अनिल भारद्वाज, जो कि फिजिकल रिसर्च लेबोरेटरी अहमदाबाद से ही हमारे साथ जुड़े थे, जिसका कि पुनः प्रसारण हमने अपने नेशनल साइंस एग्जीबिशन प्रोग्राम में 10 फरवरी को भी किया था। ये सारे प्रोग्राम हमारे एनसीईआरटी यूट्यूब ऑफिशियल चैनल पर भी हैं। साथ साथ आप ncert.nic.in, जो कि एनसीईआरटी की अपनी वेबसाइट है, उस वेबसाइट के इवेंट सेक्शन में भी जाकर इन सारे प्रोग्राम्स की रिकॉर्डिंग्स देख सकते हैं। तो प्रोफेसर अनिल भारद्वाज ने हमें इंडियन प्लैनेटरी मिशन के बारे में बताया था 16 नवंबर को। उसी क्रम में आज का ये कार्यक्रम हमारे साथ दीपक मिश्रा जी अहमदाबाद से पुनः एक बार जुड़ रहे हैं। आपका स्वागत है डॉक्टर दीपक मिश्रा हमारे इस लाइव इन प्रोग्राम में, पीएम ई विद्या प्रोग्राम में। आज मेरे साथ स्टूडियो में मेरी सहयोगी और मेरे विभाग की अध्यक्षा डॉक्टर सुनीता फरकिया विद्यमान हैं। मेरा डॉक्टर सुनीता फरकिया से प्रार्थना करता हूं, निवेदन करता हूं कि वो डॉक्टर दीपक मिश्रा का स्वागत करें और उनके बारे में हमारे व्यूअर्स को परिचित कराएं। डॉक्टर फरकिया।
बहुत बहुत धन्यवाद गगन जी, मुझे ये अपॉर्चुनिटी देने के लिए कि मैं डॉक्टर दीपक मिश्रा को इंट्रोड्यूस करूं इस फोरम पे। सभी को सुप्रभात। डॉक्टर दीपक मिश्रा के बारे में मैं ये बताना चाहूँगी कि ये एक तो वाराणसी के नेटिव हैं एंड he has received his bachelor's degree in electronics and communication engineering in 2001 from Government G.B. Pant Engineering College, Uttarakhand. He obtained his master's degree in communication systems engineering from Department of Electronics Engineering, Indian Institute of Technology, Banaras Hindu University in 2003. In 2012, he completed his Ph.D. also from IIT BHU on the topic Joint Source Channel Coding for Deep Space Application. In 2003, Dr. Mishra joined the Space Application Center, Indian Space Research Organization at Ahmedabad. He has been involved in various subsystems, development of various ISRO projects. Currently, he is involved in designing and development of payload for navigation systems, technology demonstration payload and communication module for Gaganyaan project. He is currently working as a scientist, SG, and he has more than 75 articles in various international journals and conferences. He has 3 patents in one copyright in his credit. He is focal person for signal processing module of postgraduate courses of United Nations SETCOM course and faculty member in the navigation systems course. Welcome sir, Dr. Deepak Mishra. We are fortunate enough to have you, and definitely our viewers, they will be benefited from your talk. Thank you so much. It's over to you, sir.
Yeah, thank you, madam, for my brief introduction. Let me thanks to NCERT team to give me opportunity to share my thoughts over the Indian space program. And it's a long back program. Even my born also has happened after that, when the space program has been started in India. So I will just start it with the one slide where basically it will tell the journey of Indian space program. So if you can remember, earlier we have a 2 rupee note where the Aryabhatta satellite coming on the currency of 2 rupee note. From there we have now at 1000 rupees. So the amount is also increased and the satellite volume is also increased. The complexity is also increased. Now we have see that at 2000 baht currency, now we have a Mars satellite photos on the currency. So this is basically, I can say in one word, where we are that time, where we have started that time, and now where we are right now. So this is the basically journey of Indian space program. Now, before going into detail how we have started and all, there are 3 important pillars for any space program. One is the rocketry, where we need to develop heavier and heavier rockets. Then we have a satellite technology, where we need to build the complex satellites based on the requirement and based upon the trends and based upon the country needs. And the third is obviously all this thing is doing for the development of the nation. So the various applications which are basically related to the satellite has to be demonstrated at the ground so that can be benefited to the common man. So these are the 3 important pillars for any space program to be basically grow thoroughly. Now, I am basically satellite person, but as I mentioned that the pillars are the rocketry also. So I am just giving you the brief view about the rocket technology, where we have started and how we are right now. So if you basically search about the Indian history, the rocket science is basically what I came to find out is started from the basically regime of Tipu Sultan. Basically, he used to use the rocketry against the basically Britishers against the war, and a small bamboo stick with 2 kg of gunpowder they used to fire the Britishers army, and that is quite havoc in the British army, and they basically very annoyed about this. This rocketry is still displayed in the Artificial Museum in London, and from there I think what we basically came to know that the rocket science technology still exists at that time also, but not in a big way, but in a very small way, and it can be using as a warfare type of technology. Now coming to the India beginning, actually if you see that after once we got the freedom, space technology is a very costliest technology, and at that time when Sarabhai is basically trying to force the entering of the India in the space technology, people are asking the question why we need that time. But actually the Sarabhai vision is basically to use the space technology to harness the common man problems, to solve the common man problems. And his vision not for the warfare or any other things. He saw that satellite technology should be used in solving the real-time problems of the common man in India. Using this vision, he has initiated the space science for the India, and it's a very humble beginning, and it's basically a place called Thumba near Kerala coast, where he started this rocketry science for the ISRO. And if you ask me about the Indian rockets, the first rocket was launched from the territory of India in 1963, although this rocket is not assembled in India, but is the first demonstration of Indian land as a sounding rockets. I will just brief you what is about the sounding, don't worry about that. But just first, as a startup, it started from 1963, and then in 1967, Rohini 75 is the first rocket which is made in India, and it is launched from the Thumba. And it is our ex-honorable President, Dr. APJ Abdul Kalam, the man behind it. After that, there are a lot of sounding rockets. Basically, sounding rockets are launched initially basically to study the upper atmosphere of the Earth. So at various sites, this rocket is going and to study the atmospheric, troposphere. You know, the upper atmosphere is lot of layers are there, troposphere, ionosphere, and all these things. So each rocket has every rocket has its own, means basically to study the various layers of that. So if you see that these are the tables which launched from the Thumba. In fact, they also, these sounding rockets are launched from Thumba place to study the upper atmosphere of the Earth. So each rocket has different capabilities. See the number of stages, payload carrying capacity, the payload mass, and their altitude. So these rockets are basically to study the upper atmosphere, and each has a different capability. Now, this is about these rockets have basically very small duration and very small payloads we can bring it, and the duration of the payload experiment is also very small. But this is not the goal. Our goal is to use the basically satellite technology to have a long-term applications and the long-term cater the long-term country requirement. So in order to cater this long-term requirement, our ex-president Kalam Sahab has started the rocketry program in a big way. So it basically, if you see this slide, it is started from SLV-3, where in 1983 Kalam Sahab is the project director for this, and various complex technology has been demonstrated using this rocket, like solid propulsion at that time was used, although there is no closed loop guidance that time, so it was open loop guidance, and it is for the orbital mission. So if you see that this SLV-3 weight is around 17 ton, its payload carrying capacity is only 40 kg. So based upon that, once we got the success of SLV-3, we got the mastery on that, then we upgraded the rocket and then become its ASLV. ASLV, further we increase the payload capacity. Our idea is to keep on increasing the payload carrying capacity, so that more and more application we can demonstrate from the satellite. More and more application we can cater. So we have always need to further increase our rocket payload carrying capacity. Then our development is still on. It is on and on. So then in 1994, a big workhorse I can say of the ISRO is PSLV come into the picture, and it has it is still operational, and it have a very good payload carrying capacity of 1600 kg on the space. And I can say it's a workhorse currently, and it's a very good launch. You see the list number of launches. It's a very good success rate of the PSLV. Then we required some geo satellites. I will later on come why the importance of geo satellite come into the picture. But geo orbit is typically around 36,000 kilometers. So now we have to send the satellites in much bigger space. So for that we required more and more powerful rockets. Then to come to the picture of GSLV. So GSLV basically we used to basically launch the satellite in the geosynchronous orbit, and it's a lift-off weight of 450 tons, and it can carry up to 2,000 kg of the payload mass on the geo orbit. But now this GSLV also become, I can say, is not carrying all the requirement of the country. We still require more and more heavier launch vehicle. Then is come to the picture of GSLV Mark III. If you see, just remember that the Chandrayaan-2 just we have launched last year itself. So there we have used this GSLV Mark III, and it has a further increase in payload mass ton. Now it becomes the carrying capacity of 4,000 kg. So again, we are not stopping it here in that place. We are further in upgrading our rocket technology, and our next target is around 6,000 kg, and so on. And further, we want to more and more complex rocket technology in terms of technology. Also, we are working currently to cater the need of the country requirement. So basically, idea is to have a self-reliance, and we need not earlier, if you remember, our earlier satellites of INSAT satellites are basically launched through French Guiana. We need to give the launch contract, and our satellites will go there and launch through the French rockets. But now, more or less, we are now, I can say, the self-reliance in terms of launching capability, having this type of launcher on board. Now, as I mentioned, that there are various pillars of the space program. So, in order to cater the national development, so various centers has been opened in various parts of our country to cater these 5 important pillars. One is satellite communication, another is the launch vehicle, then we have Earth observation, then we have a space exploration, and then another important aspect is coming now very fast is the satellite navigation. So all these 5 pillars need to be catered throughout the nation requirement. In order to do that, we have a various centers across the country, across the place in the country, and apart from that, we have a various applications. Now we are already targeting, or some new applications which are coming. Also, we are trying to target using this space technology. So the current applications which we are now catering is like agriculture, forestry, fishery. Don't worry, I will explain how the space technology is basically helping in this technology. But these are the some listed applications where we are using our space technology to further improve our agriculture growth, forestry monitoring system, fisheries, all these things. So if you ask me the 6 decades of Indian space program, we have approximately 80 launch missions, vehicle missions, 111 satellites realized. Apart from Indian satellites, we have some foreign launch also, and 342 satellites from 34 different countries we have already launched using our launch vehicle. So this is basically tell us our till now the development, and now we are in very much in the commercial domain. And recently you came to know that our government has now opened the space policy for the private players also. So idea is to more expedite and more faster growth in the space program. So I just give you some important launches which will happen in Indian space program, which are basically huge gathering of the news. That is one you heard that the 104 satellite in the one launch, where we have 2 Indian satellites, Cartosat 2 and 2 nano satellites of 19 kg. Apart from that, we have around 88 satellites from those satellites, Lemur satellites, and all this there. So this is basically shows our capability. So in a single launch, we have launched approximately 104 satellites. It has been launched through our PSLV and around the year 2017. Now coming to the satellite program, Indian satellite program, as I mentioned, started from very in 1975 itself from Aryabhatta. And then we have divided our satellite program in various segments. So it started from INSAT series, then IRS series, then the radar image satellite, then the Gaganyaan satellites, then the IRNS satellite, and then the various scientific missions like Gaganyaan, Chandrayaan, and all this. Today, I will try to cover this INSAT class of satellites, then the navigation satellites, and whatever the scientific missions we have launched and what we are planning for the future. Now, coming to the INSAT satellite, there is a paper from authorship, a very fundamental paper. Basically, in this paper, they have demonstrated that in order to cover the complete Earth, we required 3 geosynchronous satellites to cover the whole Earth. And the distance of these satellites is approximately 36,000 kilometers from the Earth. And the revolution speed of these satellites is equal to the Earth speed. The advantage what we get, we need not move to the satellites, and these satellites will be always visible for the same place from the Earth throughout 24/7. So this basically shows the importance of the geosynchronous orbit. So in very few satellites we can cover the whole Earth, and so this basically what I meant to say, only few satellites is required to cover the whole Earth. Basically, in each satellite there is a terminology called transponders. So each satellite typically takes around 36 to 54, or now some bigger satellites carrying the 72 transponders. So basically, what is this means of transponder? Basically in satellite ISRO Center Ahmedabad, we basically designing these transponders, and all the private players like Dish TV, Tata Sky, basically they try to buy this transponder to basically cater their program to the common people. This satellite transponder, as you see on board, there is a 3 major blocks. The signal which is transmitted from the hub basically goes to the received by antenna on the onboard satellite, and then it is passed through because the signal which we are receiving on the satellites are very weak, we need to amplify. But this amplifier is not the common amplifier, because this amplifier basically, if you are transmitting signal from the Earth, it is buried in noise. So basically, you should see this terminology, low noise amplifier. The idea is only amplify the signal, not the noise. So basically, we have a special type of technology that is called a low noise amplifier. So this will basically amplify the uplink signal from the Earth. Then our downlink frequency, in order to have a different downlink frequency, we do have a frequency converter on board, which converts the uplink signal into the different frequency so that it cannot interfere to the uplink frequency. Now we have to broadcast this signal. So in order to broadcast, our signal should be sufficiently high powered. So for that, we have an onboard high power amplifier, and this will basically amplify the uplink signal, and then we have a broadcast. So basically, this type of block is called as a transponder on board. So that is a block diagram point of level. But in terms of technology, if you see, we call in terms of satellite designer the LNA as a low noise amplifier, a local oscillator to mix the down converter frequency. Then we have a TWTS, so high power amplifier, so that will amplify the uplink signal, downlink signal. And then we have a filter, and then we have a downlink signal. So this is a typical transponder for any satellite, which nowadays we are seeing on board. Now, in terms of satellite coverage, we have a various type of requirement. Like we have a broadcast, like a television broadcast. Now people are seeing it. It's a basically called a global coverage. One place and to various throughout the Indian region. That is called a global coverage. But apart from that, satellite has been used for the spot beam coverage, like one-to-one video conferences on all these things. Then one-to-many also type of conversions also there. And sometimes steering or scanning the coverage, means sometimes dynamic shifting the broadcast. That is also called like war type of situation where we need to steer the coverage throughout various places. So that is called a steering or scanning coverage. So based on the various coverages, the satellite technology is also involved. So if you see like band pipe transponder, as I mentioned that a transponder, so transponder technology is little bit also changed based upon the requirement. So if you see the broadcast band pipe transponder, like broadcast type of transponder, is a very big coverage area. Band pipe transponder where we have a one-to-one type of video conference where there are very small beams, but various beams are there. Apart from that, there is a hub requirement is there in the band pipe transponder. If you remove the hub requirement and the hub is already on the part of satellite, then it's called an onboard processing type of transponder. So like band pipe transponder typical application is like VSAT. So where VSAT is basically various users are there which are uplinking the thing, and then it will be downlinked to the various terminals like this you can consider as our Tata Sky antenna. So user terminals will receive the signal and then it will go for the terminals for the display of the things. So this is typically band pipe transponder. In future, what happens in the trends like that, if you see there is a hub sitting there which is uplinking all the programs, and the satellite will just basically downlink the signal. So if you remove the hub requirement, then our ground stations will be more simplified. And the future satellite, what we are working right now to remove this requirement. So the satellite will be autonomously transmitting the program based upon our requirement. So basically this is our future satellites where we directly VSAT to VSAT transmission is possible. Now coming to some important satellites. As I mentioned earlier that the Aryabhatta is our first satellite which is built by India in 1975. It was India, I can say, the first satellite, but and it has been launched by the Russian launch vehicle, and it has been named our based on our great astronomer Aryabhatta. And basically the purpose of this satellite to study the X-ray astronomy and the solar physics. And as I mentioned that it has been launched by the Russian launch vehicle, Cosmos, in 1975, and it has been already at the currency. So this is basically the satellite profile. It has a weight of 360 kg and has the onboard power requirement of 46 watt. And it has a basically payload to basically study the astronomy, astrophysics type of there. It's a lot of sensors are there, and it has a very small telecommand rate of 148 megahertz. Orbit is low Earth orbit at 560 cross the 600 kilometer, inclination of 56 degrees. And it's a very small mission life. Earlier we don't have a larger solar panel like now we have, so that our satellite mission is now about approximately 15 years or 20 years now we are targeting. So it's a mission life of approximately 6 months, and nearly it has finished around 1990. Re-entered after 17 years. Already it been decommissioned long back, but it has re-entered in the atmosphere in 1992. Now coming to our current state of the art, this is just our beginning. But if you ask me what are the current state of the satellites, so now if you see that the complete world is moving towards the concept of high throughput satellites. What is the meaning of high throughput satellites? In a single satellite, we can have an enormous of data transferred to satellites. So that is measured in terms of gigabit per second. Earlier we have a throughput of megabit or kilobit per second. Now we are basically targeting about the gigabit second. So currently, if you ask me, this is the maximum high throughput satellite of India, that is called a GSAT-11, which is already on board, and it has been I6K bus. This is the bus technology. Normally we call as a payload vehicle. Means basically that is defined as the size of the satellite, and this throughput is 16 gigabit per second. It has a 32 spot beam, the beam technology which I already explained. So it has a covered complete Indian region in 32 spot beams. There are 8 hub stations. They are in complete covered in each beam, and it is a very advanced frequency spectrum. Basically, this satellite is working in Ka band, and a lot of frequency reuse, means same frequency of uplink we are reusing because of the availability of spot beams. And this is our current state of the art satellite there, and it is comparable to worldwide state of the art satellites. Now coming to the GSAT-11 technology, there are various onboard technology we have demonstrated using this satellite. Like as I mentioned, this is the first very high throughput satellite. Lot of high onboard power management, multiplier amplifiers. All these things are there on board to cater to meet this requirement. Now coming to the future, currently we are working on more advanced satellite like GSAT-20, which is on ICE 4K platform, and its throughput is basically, as I mentioned, that throughput basically defines the how much effective that satellite is. So here we are targeting a throughput of 50 Gbps per second, and it has a 32 Ka-band spot beams and 4 hub stations. So basically this is a very advanced satellite, and these satellites will be reached in the space. We can provide in India internet through satellites. So the various players is already booked their transponders to provide the internet services with these satellites, and we are working in this satellite. Satellite is almost ready. We are now just final testing. Once this satellite is in there, it's a very big boom for internet technology through satellites. So this is the current status of the GSAT-20. Apart from that, we have some technology demonstration satellites. As I mentioned, we are also working on some advanced future technology. So this satellite is already on board, and it has a basically Ku and Ka-band spot in basically the regions which are very critical for Indian scenario like Jammu and Kashmir and northeastern region. So there is a spot beam for that, so that where the people are not reaching to telephone or normal things, so satellite phones are all there. And now, because if you see that in the satellite, we are now migrating more and more higher frequency, because the non-availability at lower frequency bands are almost getting saturated, and more number of terrestrial interference is coming. So future satellite basically will work on Q and V band. Basically Q and V band are the bands where above 30 gigahertz. So up till now, ISRO has worked on up to 30 gigahertz of satellites, but now in future we need to move on beyond 30 gigahertz. So we are now basically working toward the more than 30 gigahertz band, and that is called a Q and V band. Obviously, when we are going much higher bands, more and more complex technology will come into the picture. The design hardware, the design technology will be getting more and more complex. So in this GSAT-29, we have basically attempted this Q and V band payload, and we have just 2 beams. Basically, we want to just see the performance. So we have just 2 beams in Ahmedabad and Delhi region, and each transponder have a wider beam bandwidth. Earlier, if you see that in the C-band payloads, we have a bandwidth of 36 megahertz, but if we go on higher and higher bands, we have a much larger bandwidth. So if using the technology of Q-band, we have now each transponder bandwidth increased from 36 megahertz to 125 megahertz. And it has an inter-beam connectivity. So this is basically the uplink frequency and the downlink frequency. You can see that uplink frequency is around 43 gigahertz and the downlink frequency is around 38 gigahertz. Apart from that, this is already in the RF domain. Now in future, we need to go for higher throughputs in optical domain also. So optical domain, we have just demonstrated one payload where we try to establish a link in the optical domain of 1 gigabit. Obviously, this technology is much more complex than the conventional payload, but we have attempted in this satellite, and we are just now in the testing phase of this optical link. Now coming to another complex satellite that is called a GSAT-6. This is also a very important satellite coming to India. I know that lot of unmanned railway crossings are there, and lot of accidents happen this unmanned railway crossing. So our Government of India initiative in this satellite, basically what we are planning to have a router at the engine on the railway engine itself, and they are connected to the satellites. So once the train is about 1 kilometer away from the unmanned railway crossing, the router will start shooting that. So people will aware that the train is coming. So this pilot project is already started using this satellite. So basically in this satellite, we have divided the complete Indian region in 5 beams, and each beam will basically cater the requirement of each railway engine with various router technology. So in this onboard technology point of view, we have a very big antenna, like 6 meter unfurlable. The picture you can see here is basically the open view of this 6 meter unfurlable antenna. So we have a very big antenna on 6 meter unfurlable antenna on board in this satellite. We have a 5 spot beam, and we have various terminals in the various projects. So this is also one of the technology point of view. So till now I have talked mainly about the satellite technology, about the launch vehicle, but all these things are basically in order to, as Sarah White Green should be used for the societal application to solve the common man problems. So if you ask me about the satellite application, there are enormous applications. Still, if you ask me frankly, still there are a lot of applications are there where we are still trying to achieve it. But today lecture, I have tried to push some few various applications which have already catered using this current satellite technology. So one is very important technology like a MSS type of service, that is in short MSS, called MSS, but like mobile satellite services. So if you see that in the vehicles, like in transportation vehicles, we need to track the vehicle, where my current vehicle is there. So basically idea is to have a GPS receiver mounted in these vehicles, and the GPS, based upon the GPS location, they send us their current location through satellite, and through satellites it will go to the hub station, and through hub station it will go to the control center of individual transport managers. So they will track it, where my vehicle is and where it has been stopped. So it is a very important to efficient transportation. Lot of other applications, like if you are sending some important documents or some important applications where we need to real-time tracking is required. So these MSS applications are now available throughout the India using the MSS terminal. So these MSS terminals are ready. You can mount it any vehicle and you can get their real-time tracking application. Second application is the satellite-based SMS services. So particularly these type of services are very important, particularly in disasters where every thing of communication has been destroyed. So you can send this is a portable terminal where we can just send your messages where you are and what we can do. And even for the fishermen also, suppose they got lost in sea, so they can send their messages through this small terminal. It will go through the satellite, and through satellite it will come to hub, and through hub it is connected to email. So the competent authority will come to know that some person need a help. So this is also very important, I can say, the activity using the satellite-based services. Apart from that, as I mentioned, that the next basically revolution will come the satellite-based internet service, wireless, and particularly it is very important for the remote location of India, where we don't have a fiber optics cables or anything are there. So using the satellite services, it is possible because the satellite advantage is that we are independent of geographical location. So particularly this is very important for the remote locations where we can have internet services provided to the satellite links. So basically idea is to have the internet services, one for the uplink and one for the downlink. So uplinks will go to the different satellite to hub, and the downlink signal will come through another satellite and it will go to provide the user requirement. So, so this type of concept is already there in Indian satellite, using Indian satellite services. But as I mentioned that more and more high throughput requirement, because the satellite, right now the satellite bandwidth are very small. So now as I mentioned earlier, using GSAT 20, we are giving to the bigger bandwidth, so that it will be more compared to our terrestrial internet service bandwidth type of things. Now another thing is like cyclone warning type of scenarios. See, we have deployed lot of warning system in sea, coastal places and all these places. So basically they will keep on assessing the scenarios of around the things, and once the cyclone will come, they will send the real-time information to the through satellite to the control center, and based upon that our government will prepare in advance. Now if you see in previous 3 cyclones, which major cyclones which come India, Indian government has done the fantastic thing. That is possible because of this cyclone warning system. So they will basically mark you in advance what type of cyclone is coming, and based upon their information, government can plan in much in advance. So this is also now in operational, and it is in place in lot of places where the cyclone frequency are very large. Another important aspect is the satellite aided rescue system. India is basically, it is an international commitment. India is also part of that satellite aided this search and rescue. It's an international, basically I can say the international commitment, various countries participating in this, and India using our INSAT class of satellite is also participating in this. So like certain ships which require urgent help, they have this type of terminal, they can send their signals, disaster signal, distress signal to the satellite, through satellite, and their signal will receive at the control center. And not only through Indian satellite, as I mentioned that there are other countries' satellites also participating to cover the globe. So anywhere in the world, in the sea, if any ship is in distress, they will send their distress alarm through satellites, and using this control signal, they will very fast they will get the rescue operations. So this is also an international basically operation where India is also a part of that. Now coming to some real scenarios, like practical scenarios in India, where we still use the satellite-based application. One is the like education scenario. You know that India is means basically our literacy is not at par compared to the developed country. We need to improve it. The various drawbacks, basically, if you ask me, that there are various reasons for that. One is the level of qualification, teacher availability in the remote, particularly in the remote places. And there is a study basically which says that the 87% is the dropout by class 12 standard of the Indian student. So in order to improve, obviously we need to improve our education infrastructure. But at the same time, immediate relief is that we can have a tele-education type of concept which is coming in a big way now. And this is called as EduSet, and we have a dedicated education satellite that is called EduSet, has been there. So basically the objective is to provide efficient teaching training programs, supplementary curriculum activities based teaching, and it is independent, since it is independent of geographical location, so it is particularly important to have a quality of education, particularly for the remote places. So there are various ways to do that, and some already has been implemented, and some we are now again working on that. So various modes where we can deliver this EduSet technology. One way, the one-way broadcast, TV interaction broadcast, video conferencing, teleconferencing. So these are the various modes of delivering the education through satellites. And now, if you see, ask me, currently we have a dedicated satellite, and already various EduSet network has been operationalized in various states of the India, and various big universities are already participating in that. But the idea is to have more and more, particularly in the remote places. We have some installation of the remote terminal, so they can also effectively, basically, can participate in this EduSet program. This is just one snapshot of one where we have just installing the EduSet network. Now coming to the health scenario. Now this health scenario in current scenario is more critical, particularly if you see this the corona case. So now India health infrastructure, I can say that it is good. Now it is improving, but still we have a lot of work need to be done. And particularly if corona type of scenarios where a huge people is getting affected, this tele health education is also very important. Where the idea is to connect some very good hospital to the remote hospital so that they can get the immediate relief, particularly in the critical scenarios. So if you ask me that the big cities in India have a very good hospitals, but in the remote places the availability of good doctors and good facilities is not there. So using this telemedicine facility, we can have basically a video conference. Using video conferencing, we can provide the immediate relief for the remote places. And this is basically the concept where the remote places hospitals are connected through the satellites, and even some moving vehicles where even the health centers are not there. We can deploy the moving vehicles where the patient can be accessed through a satellite to a big hospitals and super hospitals, and they can our super specialist doctor can advise or can give the proper medicine through satellites only. So this is one. Just I am giving you one snapshot. Where you can see that in the Mysore, where the district hospitals are connected through through satellites to a Narayana Hospital, Bangalore, and even some super specialty doctors need to further consultate. They can connect through ISDN line through the super cardiologist of the Kolkata hospital. This is one tele-education scenario. So this needs to be further worked out for the future, like Corona type of scenario. So this satellite technology is also very helpful on this. And now this is our current application, but now you see that now more and more we are going towards the like machine learning and type of things where the human involvement are getting reduced and reduced. So we are now working on new application trends where automation is, we are more focusing towards the automation so that there is a less human intervention is required for the future satellite based applications. So we are now, our new satellites more towards the machine-to-machine type of things, where human interventions are less. So these are the future technology which I can say will be required for the India development in future using our future satellites. This is all about this future communication scenario. Another important aspect, as I mentioned earlier in my presentation, is another important aspect is coming the space-based navigation system. So this is also coming very big way, particularly in Indian requirement scenario, independence requirement. So if you ask me about the current trends of satellite-based navigation system, so it can be divided into two parts. One is the global navigation system. So you heard about the GPS, Galileo, Kronos, Pidu. So these are the basically global navigation system. And India is basically called as a regional navigation system. The regional navigation means it only caters the basically Indian region requirement, not the for all global. So these pipes are basically global. So they cover the complete globe. but the regional navigation system basically covered the navigation requirement of particular region. So there are three players: QGSS from Japan, GDU from China, and India's own navigation system, which has been named by our Honorable Prime Minister, called NAVIC. So this is basically snapshot of all the navigation players. If you see that the GPS has around 24 satellites, and they are working in MEO orbit, medium Earth orbit system. And I earlier mentioned that the GEO required less number of satellites to cover the globe, any part of the Earth. So NAVIC system basically need to only cover the Indian region. So we have gone through in the GEO orbit, and all the NAVIC satellites is in the GEO orbit system. Okay, so compare like another any satellite system, it has a 3 segment in the navigation. We have a space segment where we have a satellite on board. So NAVIC currently 7 NAVIC satellites working on board. So the purpose of this NAVIC satellite to basically to send the continuous positioning parameters from on board to the ground terminal. So like in mobile receivers, we have now GPS receiver. Very soon, all the mobiles which are going to sell in India have a NAVIC chip on board. Okay, so basically this information the mobile is getting through this satellites only, and this satellite purpose is to provide the round-the-clock services to the user terminals. As second part is the control segment, where this all information which passes through satellite to user need to uplink to satellites. So this is basically called as the control segment, where all the critical information which is required for the positioning or precise positioning will be passed through to the satellite to the user. Another last thing is the user segment, like different receiver, like mobile receivers, and for the defense we have a very critical defense receivers, particularly for the CRG, the type of places where this receiver has been used, and particularly important in the war scenario. So NAVIC evolution, this we have come very late. GPS started very long back, but we started very, I can say very late. In 2003, we have a just system study concept. Project finalization has happened somewhere around 2008, and then we started launching of the satellites. And the operational phase is within 7 years. We have a complete operational satellite, and now we are planning to further extend for the more, particularly for the defense requirement. Apart from that, earlier satellite we have only 2 bands of operation, like L5 and S band. Now we have an additional service which is for the civilian users in L1 band, which is planned to from launch from IRNSS 1J. Up till now 1I has been launched, and from IRNSS 1J onwards we have another band that is called L1 band. So these are the basically, if you see the navigation phase-wise development, we started 2008 and various phases we have launched in various satellites. Currently we are providing 2 types of services in 2 different bands. One is called L5 band, another is called S band, and we have a 2 types of services. One is called open services, that is for common people of India. Another is called the restricted service for our defense people. And because idea is to have if you remember, during the Kargil war, GPS has diluted the position of our region. That's the reason at that time our defense people have suffered a lot. So in order to do the independence navigation system, we have now providing the restricted service through our own navigation satellites. And we have a very good operational right now up to 7 satellites. In future, we are further extend the constellation to have a more precise positioning system. So this is our current coverage, and this the yellow one, if you see that our future plans. Right now, if you see the white one is basically our satellite coverage or till our NAVIC satellite. So as I mentioned that we have a type of services, the standard positioning services. We have a 20 meter of accuracy over the Indian region, and it has been operating in 2 bands. Then we have a restricted services, which is much better accuracy compared to the civilian things, and it has a 2 frequency band, L5 and S band for the military purpose. So this is the complete, I can say one PPT for the complete, where we can see that all 7 satellite, operational satellites. We have a ground control center at Bangalore. Then we have some CDMA ranging stations at various places in India. So this is the complete operational configuration of the current NAVIC configuration. Now this is our present basically configurations. We have a 7 satellites in GSO orbit or in IGSO. We have various ranging stations at different places. We have a 2 frequency band operation. And we are now extending our basically, I can say, the configuration. Now in future we have 11 satellites. Apart from current L5 and S band, we are now extending for L1 band. Now, why this L1 band is important? Because if you see any mobile or any dual band receiver, there are 2 bands. One is called L5 band and another is called L1 band. Up till now, in previous satellites, we don't have any L1 band. So we are now in the next satellite onwards, we have an L1 band signal also. But the problem is when we ask for the GPS and other fellows to share their signal structure so that we can have a have a transmission of L1 band, they denied it, or some condition they have put it. So using our own development, in fact, I was the part of that team. So we have completely designed our own signal for the L1 band, and now it has been part of the satellite. And the next satellite onward, complete Make in India L1 band Navic signal will be there. So these are the basically you can see the it is not basically for the common for the basically just I am giving you the glimpse. This is the design which we have developed in house, completely made in India, and this is now going to transmit on the next satellite onward. Apart from that, now as I mentioned that the Navik is now part of all the major receivers, all the car manufacturers now they need to incorporate this Navik signal in their automobiles, in the mobile chips, all will come into big way now. So we have already tied up very cheap manufacturers. So these are the few chips where the Navik is already part of the industry, where we see that there are various chips now they will be integrated in the current mobile manufacturer, current automobiles sector, all the missiles technology, but for the defense also. So they were now migrating towards the Navik rather than the GPS. Now coming to the space scientific currently, as already Gaganji has mentioned that it was already discussed during the last lecture. But I want to just give you some glimpse what we have done it and what we are planning for the future. So as you know that the Chandrayaan-1 has been launched long back, and their major 11 instruments are there, and the major finding that time is the water molecule on the lunar surface. Apart from that, from the ground stations, we have developed a very good ground station where 32-meter antenna is there. So as per the objective point of view, we have discovered a lot using Chandrayaan-1. Apart from that, we have a very successful Mars mission, and where we have basically to study the Mars atmosphere and Mars and Mercury atmosphere and Mars topology of the Earth. Apart from that, we have an AstroSat to basically study the UV rays study about the multi-wave UV X-rays observation. Then we have a Chandrayaan-2 where we have explored the moon and then the orbital and land rover. Now, apart from that, we have very good upcoming missions like Aditya-1, which basically study to the sun very thoroughly in terms of their coronal heating and magnetoscopic phenomena. And then we have a very called Gaganyaan mission. So I will just take you some important mission which has been completed and then what we are planning for the future. Like if you see this picture has been taken from our Mars orbiter camera. So basically idea is the Mars mission is to have a complete study of the Mars meridian atmosphere, Mars land and all these things. So it's a very unique mission in terms of optimization, in terms of satellite design, in terms of launch vehicle capability, and we have optimized a lot to have a successful mission. So in this Mars orbiter mission, so this is the basically satellite, you can see that. So various components of the satellites, we have a solar array, we have a propellant tank fuel basically, then we have an antenna design, then we have a payloads on that. So there are 5 payloads in the Mars mission, basically named as Mars color camera to have a Martian pictures. Then we have a thermal infrared spectrometer. Then we have a methane sensor to find out the methane on the Mars atmosphere. Then we have a composition analyzer basically to study the Mars composition. And then we have a photometer. So these are 5 very critical payloads based upon our launch capability, based upon our satellite design. We have launched through the Mars mission and it has been very successful. I like to highlight the one important feature. This initially once we have planned this mission, it is for 1 year. But due to our meticulous design and precise orbit injection, this mission is still on and still giving very good amount of data to study about the Mars. And this satellite is still operational and it is giving us the very important data about the Martian atmosphere. And these are the 5 payloads which have been mounted at the satellite. You can see that the way we have mounted these payloads on the satellite deck. So various payloads, as I mentioned earlier, there are 5 payloads have been mounted at various places in the satellite deck. Now coming to our future mission, this is one of the I can say one of the most prestigious mission for our future program. This is the Gaganyaan program, and I was also basically I can say the part and parcel of this mission. I need to develop the crew communication module for this mission, and basically the idea is to have a crew member. The ultimate result means ultimate goal is to launch 3 crew members on board using Gslv Mark III. As I mentioned that currently we have a very advanced launch vehicle. We have a 4,000 kg ton capability lift off mass and then to launch them in the space and safely bring back them. So these are the basically ultimate goal for this our Gaganyaan program. And due to this corona pandemic, we have suffered a little bit in terms of launch. Earlier we have a launch of this year, means 2020, December 2021, but due to this pandemic, we have delayed by 1 year. And basically, we have divided this program into various phases. So our initial phase, we will just demonstrate the technologies which are required for this mission, because here the human life is involved and we do not want to take any risk for the human life. So we divided into various phases to have a validation first the technologies and then the real mission. So we have a various technology development phases. So as far as the rocket technology is concerned, we have a 2 unmanned missions before the final manned mission. So this is planned now in December 2021, first unmanned mission. Then the second unmanned mission after 6 months in July 2023. And then we have a final 1 manned mission, which is for 7 days in December 2024. It's a very challenging mission in terms of technology, in terms of complexity of launch complexity. So here we basically, if you see this, our launching, what we need to launch is basically 2 modules. The first upper one is basically called a crew module, where the astronaut will be sit, and this is called a service module. Basically, this service module will provide all requirement of astronaut during the orbital phase. So these 2 will connected together like this, and they will put in the rocket top heat shield. Basically, you can see that in this figure, this complete module will be sit in the top of the rocket, and this will launch in the orbit. While this will be connected together during the orbital phase. So this you can see that the rocket will go in the orbit, approximately 120 to 400 from LEO orbit. And during the orbital phase, this crew and orbital module will connect it together. Then we have a deployment of solar, so that this orbital module will get the required power to have all this communication link. Then after 7 days, we need to reorientate this vehicle. We need to remove this module from the orbital module, 2 modules from the orbital module, and then we have a splash down somewhere in the sea. So all these phases has a very criticality and very precise injection is required. So right now we are basically doing the certain simulations, certain hardware verification, certain level of testing is going on at various places in the ISRO centers. And I am sure we are like Mars mission will get the success in the first attempt itself. We are quite confident about that. Only thing is that we are not taking any chance for any mission profile, and we are taking all necessary precautions to have a successful mission in the first attempt itself. Now coming to the applications, various diversified applications. Already I mentioned that this basically our ISRO is not working toward that have a certain advanced things. We are basically working to solve the common man problems. So the common man problem is like agriculture. We should have a crops, basically have a production estimation of various crops. What is the Rabi season estimation? What is the, so that will basically help to our farmers to have a prediction so that they can be ready if there is a drought scenario will coming the next year. So these all basically toward the agriculture. Their satellite will play a critical role. Similarly, like drinking of water, we know that now the groundwater resources are getting critical based on our requirements. So finding of the groundwaters and borewells, boring can be, now it has been operationalized in few states of India. So the drinking water is very critical. Like in fisheries also, fishermen are going into the sea to catch the fishes. But using the satellite technology, we can guide them where the maximum fishes are there. So like fishery applications, now the satellite technology is working very well. Watersheds finding, so where the watersheds, better watershed development is there. In irrigation infrastructure, like various, where the good, like what type of soil moisture are there, this type of things are there. And then the various records, like ice record, land soil records, various geometric records, where the land degradation is happening, where the snow glacier conditions are there. These are required, very much monitoring is required. So all this is possible using the satellite technology. So various diversified applications are there. Similarly, other applications like forestry, we have to keep on monitoring. And now the like panchayat planning, like talukas planning, now we have connected to that. So these are called one very good application using satellite technology, where all the panchayats are connected to that. Glacier monitoring system, where all the glaciers has been monitored through and they will give us the future trends also, how these rates are monitoring. And our dedicated team is basically monitoring all the snow barriers. Weather, you know that now more and more cyclones frequencies are now very prominent. So this weather monitoring is also now very critical, and more number of weather satellites we are planning in future to have a more precise basically weather prediction, climate prediction is there. Apart from that, now you see that as our country population is increasing, we have to do the urban monitoring is also very, how much the urban geography is there. So in order to do the future urban planning, infrastructure, e-governance, all these places, basically the space application is very critical. And now our government of India is basically has a dedicated department which basically have a handshaking with ISRO. Find out all other, apart from these applications, to find out all other applications where we can use this space technology for the basically to more better way to cater the various applications for the common man. So this is all about my lecture, where I basically try to highlight about the various applications and the various satellite technology in terms of communication and navigation. This is my email ID and my cell phone number. Already Gaganji has mentioned that you can ask your question through him also. But if you have any particular want to any detail or any particular information about the ISRO, about their technology, or about any opportunity in ISRO to working together, we have a lot of academic collaboration. We have lot of basically I can say the departmental collaboration. So you can very well contact to us. I can forward it to the corresponding team, which we are working on that particular application or particular department. So thank you from my side, and now I can take the question.
We indeed enjoyed in being with you today. You started with the beginning of Indian space program. Then you shifted after discussing starting from Vikram Sarabhai and coming through to Abdul Kalam and other efforts. You mentioned about your Rao as well, and then contributions from the different in the different eras, different timings in ISRO programs. Then you mentioned about the Indian Rocketry program. It is very important. There are some questions about that. Then let me take this point. Our questions are rather very basic. I mean, if I were to speak about the talk today, I mean that was largely informative in the sense that what is happening, how India is planning to move ahead in this space program. Indeed, but basic question in the Indian Rocketry program, I mean our children are trying to connect this rocketry system with Dhanushman. You mentioned you briefly, I mean probably I remember I can connect it, that as you mentioned about the Tipu Sultan's rocketry system, probably the word rocket was not appearing at that time, but they use the same technology. But the connecting this to the daily life, can we connect this Dhanushman technology or technique, whatsoever we may call, with the rocketry system? In brief, Dr. Mishra, please.
Yeah, actually, just for your knowledge, we have just started for the student of class 9 to 12, that is called a Eureka program, where we call from a student from 9 to 12, and it is just now on. I think if you wish, I can share their poster also. So their idea is to have a feeling of this real technologies, to how a student can make a small rocket, launch them, and to just give just, although not in the real sense, but they will just get a feel of that. So we have now just started to basically to make more interest toward this student stream, particularly from 9 to 12, because they are only now going to decide our future. So these are there, and they can very well connect with that.
What is the name of that program you mentioned?
Eureka. You can very well go on the ISRO website. It is just launched now.
Can you spell it for us? Can you spell it for us?
It is
UNIs. Can you spell?
I will send you the detail. I will send you the detail.
Okay, all right. And then you came with the development of Indian satellite program. You mentioned about the Aryabhatta and then different systems, and the India's capability of propelling the satellites. Yes, you mentioned about the space history, communication and navigation systems, satellite systems, the brief overview of Gaganyaan program, and you mentioned about Aditya as well, where the orbits are in picture around the sun. Even not only it was your talk was constraining towards the rotation of the earth or around the earth, but you went interplanetary as well, That was a great understanding from your session, and of course, in different applications. Children are enthusiastic to learn that after their class 12th, which is very basic in nature, which is very much required, a child having good understanding of mathematics, good understanding of physics, some basic understanding of chemistry as well as biology is required. Can you just, we are running short of time, Dr. Saab, can you just tell us that where they can apply? IIST is there in Thiruvananthapuram, I know. Can you just throw it light in just few sentences?
Yeah. Actually, now we have our own university, you know, that Indian Institute of Space Technology in Trivandrum, where we have basically BTech courses, now MTech courses is also there. So basically that idea is to have to directly focus our requirement. So there is a dedicated university of ISRO that is called IST in Trivandrum. Apart from that, we have now taking from the students through the various colleges of the India. There is no restriction about the going. But as you mentioned that the students should have a very good inclination toward the physics, toward the mathematics, and for the applications also we have a student. We are taking the basically student from biology background also, because this application now ISRO is very much focusing. Even Government of India is focusing. So any stream you can come down to ISRO. There is no restriction about that. But only my request is that you should have a passion to work, to have it in a particular technology. That is more important other than choosing a particular discipline. That is my only view.
Yes, you are right. You are right. I suggest my viewers to go through the IIST's website for saving more details. And we really enjoyed in being with you today. We really thank Indian Space Research Organization and Space Application Center Ahmedabad for being us in contact with you, and we really look forward meeting you again when the Indian space missions takes place in the first unmanned in December 2022, and after that sessions we really look forward having more session with the ISRO at NCERT platforms too. Thank you very much once again, Dr. Mishra, being with us, and it was really a great pleasure for us and for our children. Viewers, this was our session on Indian space program in continuation with our earlier sessions on space technology. You recall Arvind Ranade's talk, and you may recall Anil Bhardwaj's talk which took place earlier in this platform. Our next session is due on Wednesday, March 16th, when we will be having Dr. Randeep Guleria from All India Institute of Medical Sciences in our studios, and he will be talking about how to stay healthy in today's time. आज के समय में हम अपने आप को कैसे स्वस्थ रख सकते हैं, इस विषय पर वो चर्चा करेंगे. तब तक के लिए आप सबके साथ सादर प्रणाम, नमस्कार, धन्यवाद.